Hello students, in this video we will discuss about some special kind of sets. So our first topic is empty set. Okay, when a set is called empty. As you can see from the definition or from the name of the set, you can easily make an idea about the property of this empty set, right? Suppose there is a situation, consider a set A. A is the collection of all the students of class 11 presently studied in school. Okay, now what are the elements of this set? The elements are all the students of class 11 presently studying in the school. So you can go to the school and count the number of students presently studying in class 11. Okay, thus the set A containing a finite number of elements. There will be some student, okay, there will be some student from class 11 which will be the elements of set A. Now consider another set B. B is the collection of all students presently studying in both classes 10 and 11. Okay, so B contains those students presently studying in both 10 and 11. Now you can observe that a student cannot study simultaneously in both classes 10 and 11, right? That's why there will be no such students who will study in class 10 and 11 simultaneously. So in set B there will be no collection of students. That means there will be no element in set B. Okay, this kind of set is called empty set. Okay, so what is the definition? A set which does not contain any element is called empty set or void set. Okay, or null set. Now according to the definition, B is an empty set while A is not a empty set. Now empty set is always denoted by the symbol phi. Okay, or you can denote it by second bracket. Okay, but generally we use the sign phi. Okay, only phi. Don't close this phi with the second bracket. This notation is totally wrong. When you are enclosing phi with second bracket, that means it will be a set which contains a element phi. Okay, so the symbol of denoting empty set is only phi. Okay, only phi. This is the definition of null set. Now we'll discuss about some example on empty set or null set. First one is, let A is a set of collection of all x where x is a natural number and x between 1 and 2. Now can you find any natural number between 1 and 2? You know 1 is a natural number, 2 is a natural number, but can you find any natural number between 1 and 2? The answer is no. That means A is an empty set because there is no natural number between 1 and 2. Now look at example number 2. B is the collection of all x where x have to be a rational number and x will satisfy this equation, x square minus 2 equal to 0. Okay, if you solve this equation x square minus 2 equal to 0, what you will get? X square minus 2 equal to 0 means x square equal to 2 implies x equal to plus minus root 2. Now plus root 2 and minus root 2, both of them are irrational number. That means the solution of this equation, both the solution of this equation are irrational number. So there does not exist any rational number which satisfy this equation. That means B is a empty set because this equation is not satisfied by any rational number. Okay. Now third one is collection of all x is an even prime number greater than 2. Okay, this is also an empty set because you know only even prime number is 2, right? Only even prime number is 2. Now the collection, there will be no collection of even primes which are greater than 2. That means C does not contain any element, so it will be an empty set. Now 4. D is the collection of all x where x have to be odd number and x square have to be 4. Okay, what are the collection of elements whose square is 4? One is 2, another one is minus 2, right? 2 square is equal to 4, and minus 2 square is also equal to 4. That means, and 2 and minus 2 both are even numbers. That means there does not exist any odd number whose square is equal to 4. So again D is an empty set. Now we'll discuss about the finite set and infinite set. If a set contains finite number of element, or if a set is empty, okay, a set which is empty or consists a finite number of element or definite number of element is called finite set. Otherwise it is called infinite set. Okay, so let's check some example. Suppose W is a set of the days of the week. Okay, you know in a week there is only 7 days, right? So you can count that number of days: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? So you can count it. That means in the set W there is finite number of elements and the number of elements is 7. So that's why W is a finite set. Now if you collect a set S is the solution of the equation x square minus 16 equal to 0. Okay. Now what are the elements which satisfy this equation? X square minus 16 equal to 0 means x square equal to 16. That means x have to be plus minus 4. Okay, that means A set is the collection of positive 4 and negative 4 because these two elements satisfy the equation x square minus 16 equal to 0. As you can see, only 2 elements belongs to S, so it is a finite set. S is a finite set. Now 3. Let G be the set of all points in a line. Now you know it from class 9 that when you are representing a line, there is infinitely many points on that line. Infinitely many points on that line means there will be infinitely many solutions. That means if G is a collection of all points on a line, it have to be infinite. Why? Because on a line there is infinitely many points. So G is an infinite set. In this way you have to make the difference of finite and infinite set. Now there is an example. State which of the following sets are finite and infinite. First one is x have to be natural number and x minus 1 into x minus 2 equal to 0. Look at here, this is in the factorized form. If you solve it, the value of x will be either 1 or 2. Okay, that means this set is equal to second bracket 1, 2. Okay, look at here, given set is equal to 1, 2, hence it is a finite set because it contains only 2 elements. Now second one, if you look at the second one, it is collection of those natural number which satisfy x square is equal to 4. Again solve x square equal to 4. The answer will be x equals to plus minus 2. Now x have to be natural number. That means this set will be only positive 2 because negative 2 is not a natural number. So the second set contains only one element and that is only 2. So again it is a finite set. Okay. Now third one, x is this set is the collection of all natural number which satisfy 2x minus 1 equal to 0. Okay, if you take this equation and if you solve it, the value of x will be half, and you know half is not a natural number, right? So the only possible solution is half, and this half is not a natural number. That means in this set number 3 it contains no such natural number. That's why the given set will be null set and you will denote it by only 5. Now if you look at the definition of finite set, you can see that the empty set is also considered as finite set, right? So since set number 3 is empty set, that's why it is a finite set. Okay, now fourth one, x is the collection fourth one is a collection of all natural number where they have to be prime. Obviously there are infinitely many prime numbers in the number system, that's why it will be an infinite set. Similarly for odd one, okay, there are infinitely many odd natural numbers, so it will be infinite set. Now the last topic, equal sets. Two sets A and B are said to be equal if they have exactly the same elements, okay, and we will write A is equal to B. Otherwise the set is said to be unequal and we will write A not equal to B. So two sets are equal if they have exactly same elements. If you look at question number example number 1, 4 consists 1 2 3 4, B consists A consists 1 2 3 4, B consists 3 1 4 2. As you can see, in both set and B, set A and B, the elements are same as 1 2 3 and 4. The order of the elements are different. Okay, here the first element is 1, here the first element is 3. The order is different but the elements are same. That's why they have to be equal set. Okay. Now example, find the pair of equal set if any give the reason. Okay, so 5 sets are given, you have to find the equal set. Okay, A is only consisting the element 0. B is x. B is collection of x where x have to be less than 5, x have to be less than 5 and x have to be greater than 15. Okay, so the numbers which is less than 5 is 4 3 2, means it is the collection of all real numbers which is less than 5. 4 3 2 0 minus 1 minus 2 minus 3 and so on. Then the rational and irrational number is also there, root 2 root 3 minus root 2 minus root 3. Then all the numbers which is less than 5. Similarly all the numbers less than greater than 15. This collection is the collection of infinite elements. This is an infinite set. C is all the x which satisfy x minus 5 equal to 0. Obviously the only number which satisfy x minus 5 equal to 0 is 5. So C is in the roster form, the C will be second bracket 5, singleton 5. Now D is those x satisfy x square equal to 25. So if you convert it in roster form, it will be positive 5 and negative 5, because positive 5 and negative 5 both satisfies x square is equal to 25. Now E, x is an integral positive root of this equation. Okay, if you solve this equation, x square minus 2x is given. If you do the middle term factorization, it will be minus 5x plus 3x minus 15 is equal to 0. So the factorized form will be x minus 5 x plus 3 equal to 0, right? Now if you solve x minus 5 and x plus 3 equal to 0, the solution will be x is equal to 5 and minus 3. Okay, but you need the integral positive root. That means E will be only a singleton set consist 5. As you can see, E is equal to 5 and C is also second bracket 5, means E and C both contains only one element and the element is 5. So C and E will be equal to each other. Only pair of equal set is C and E. Okay, so in this way you have to solve it, and as you can see, all this set B, C, D, E does not contain 0, right? So that's why A is not equal to B, A is not equal to C, A is not equal to D, A is not equal to E. Okay, so this is all for today. Thank you.